Secret of Flight, a series of programs on aerodynamics. Program 11, The Story of the Vortex. Your host is Dr. Alexander Lippisch.
When I explained to you in one of our last programs the generation of lift as a superposition of a rotational motion around the wing and a straight flow, we call it a translation, then you might have thought that these fabulous lift forces which carry these large airplanes with several hundred thousands of pounds through the sky, that these lift forces are in some way generated by a vortex motion, and that this vortex motion is necessary to make the lift of an airplane. Well, there are many other cases of such rotational motion in the fluid. And since the vortex is so important in many cases of fluid motion, let's talk a little bit about this strange fellow. Well, the last time I think I showed you some ring vortices out of this box. And, well, since it is so nice, let's make some more of these. I think you see it better when I stand here and shoot it across our tunnel. Let's see. Now you see them? They go straight out, and it looks to you there as if you shoot just air through air. And when you look at them, you observe at once one very important law of vortex motion. See, the smoke comes out like a bullet. That means that all the particles of air which contain the smoke or which are smoky air stay together in this ring, which actually is nothing than a vortex ring. That means we know at once that if fluid is bound in a vortex, it stays together and goes through the other fluid as if it would be a solid body. On the other hand, when you look at this close, then you see that this rotation around a vortex is different than the rotation of a wheel. On a wheel, the outer peripheral parts move faster than the center. On the vortex, it's just opposite. The center moves fast and the outer moves slower. Now, how do we produce this? Well, let's think about it. Let's have a cross-section of this thing. This is a box, and there we have the bottom with a hole in it, which has very sharp corners. Now, we punch against this membrane, which we have back there, and then we produce a pressure wave which goes through here, hits these corners, and blows out a bubble of air, and then a bubble of air comes out here. This takes little particles which just were sitting here with it, and then new air has to flow towards the point where you have taken away these particles. So this motion and this motion produces a spiral motion which makes a kind of a mushroom, and out of the mushroom finally comes your ring vortex. We have made some high-speed pictures, some slow-motion movies of this generation of the vortices. And let's now look at these pictures. First, we see a front view of the box. And it's very interesting to observe first the radial motion of the air, and then the bubble is formed and comes out as a ring vortex. In the next picture, we see the same process from the side. And since we have a membrane back there which is elastic, the bubble jumps in and out first before it finally travels away as a ring vortex. Here we have another tube where we have another kind of a membrane on it, so this doesn't happen, and it looks like an atomic explosion actually. But the most interesting view is to see it from in front, which is this picture again, and observe the vortex formation before it comes out. This is most interesting, and I think it's only shown in this high-speed picture. You never can observe it with the bare eye. Now what we have seen here was that the formation depends on a flow across a sharp edge. And behind the sharp edge, the vortex is forming. Then we remember that we saw this once on an inclined plate. Actually, the formation of the wingtip vortex is nothing else than it hits the sharp edge of the wingtip, and then the flow rolls over it and forms this wingtip vortex. Let's look at this thing again in our smoke tunnel. And we have, in this case, we have just a part, the ending of a flat plate in it, and when we turn the blower on and we have some smoke, then we can very well see again the formation of this spiral vortex from this corner where the flow actually stalls away and new air from the side moves in and forms then this spiral motion. You see it here very well. And when you look at it from the side, then you can actually see the three-dimensional development of this spiral motion. Now, you know, we have made these vortex rings and the straight vortices in the air. And you might think, can you do that also in other fluids, for instance in water? Well, I will show you. You can actually do the smoke rings in water, and we have here a water tank. We don't have fishes in it, but we have a hole at the center, and underneath of this tank we have a little container with colored water. We have some ink in it, and with a membrane underneath. And when I push this membrane, then we make the same smoke rings here, the water rings, as we did it in air. Now watch this. See, I push it up and let it go slightly. And there's the smoking. Do you see him? Another one. Another one. When I make it a little bit more violent, then you see that it even jumps out of the water. What's this? Oh, this. Now we don't want to color this all up, because then we don't see our rings anymore. But I will just make one more. You see? Therefore, we can make these vortices also in such a dense fluid as the water is. Now, when you look at the rings and you see that they jump out of the water, at least at the center, you think about what sense of rotation is in there? Let's talk about this for a moment. See, we have actually here our bottom, and there's a hole in it. And now when we push, then the water comes out of it, and as I told you, forms first a bubble, like this, a mushroom, and out of the mushroom comes finally this ring, which travels up there as a true vortex ring. The center of the vortex is somewhere here, and the highest motion is in the center. Now the sense of rotation will be then this. Since we push this way, we have a rotation which goes around this way and this way. That means the outer turns back and the inner goes up. And when we now hit the water surface with such a ring where the rotation is this way, then we have a water column which now jumps out of the water here. Since we have in this center, we have the velocity against the water level, and the other ring disperses along the water surface. Now, you have probably yourself observed in water another type of a vortex. You know, when you open the sink of the bathtub, let the water out, you often observe that there is forming a kind of a funnel, and that the water begins to rotate and form such a funnel of air and surrounded by rotating water particles, which actually forms a straight vortex going into the sink. I think we can show that also here in our water tank. When we let it out, then first, due to discontinuous motion, due to some disturbances which are in there, the water which all wants to flow towards the center misses this center a little bit, and due to this a rotation begins which finally forms this funnel. Now it slowly begins. You have to wait a little bit, and this depends on the level of the water when this vortex actually develops and the size of the opening. I can see from here now that the rotation begins to form. And pretty soon you will see that due to the low pressure which is in the center of the vortex, there will develop a little dip in the water which shows us the beginning of the vortex formation as it is now. Now you see it beginning, and then it spools down. You see it now coming down and going towards the outlet. See now? And this gets stronger and stronger. You get a little wet with these experiments, but don't bother. And you can see now this vortex funnel very clear going down into the sink. The rotation at the center is quite strong. Well, let me explain to you a little bit more how this comes to such a rotation. And while it runs out, well, we can see a little bit still. We will talk about the cause of such a vortex. The main thing is that you have to have a sink. That means what is first with the formation of the vortex? What is first, the chicken or the egg? And what is here the egg and what is here the chicken? Well, the chicken is a vortex, and the egg is a low pressure area where everything flows to it. Now, when it does this, when we have this hole in the center, we pull the plug out, then all the water wants to go towards the center, because the pressure here is lower than the pressure in the surrounding water. Since we pulled the plug at this point, we have no water pressure from above. Now, theoretically, these lines and these flow lines should all come into the center. But due to little disturbances which are on the floor and which are in the water anyhow, some of the particles will not have the straight line into the center, but just miss it a tiny bit. Now, when one of these lines misses this point and shoots over here, well, then it is sucked back into it, and so this rotation starts. And then, since this missed it, the other particle which wanted to go here comes also around and does the same thing. And then finally all of them do this, and there we have the vortex. Due to the courtesy of the Hydraulics Research Institute at the State University of Iowa, we have some nice films of such vortex formation, and we can see them here, especially a film which is taken from above, where you look to the vortex formation from above, and you see very well in these films the velocity distribution in the vortex. You see where the center rotates the most, and towards the outer, the rotational velocity gets smaller and smaller. Now we see here again the development of the funnel from the side view. First, a very fine line which gets wider and wider when the rotation increases, here due to the gravitational forces which push the water out through the bottom sink. And finally, we have a big funnel with a very strong rotation around the center. The low pressure at the center is so low that we have, instead of water, we have here air in it, because the water level itself goes down up into the sink. Now we have put some dye into the funnel, and you might see the flow around the funnel itself made visible by putting some dye into the fluid. There's a picture where we see the outer motion of the fluid. If you see these experiments with the water funnel, you might remember that you have seen this too in pictures, or even, if you are from the south, in nature, as a big tornado funnel. And you might think that there is some striking similarity between the funnel of the tornado and this outlet vortex in a water vessel. I think before we talk about this more closely, let's look at some of the pictures which we got about the tornadoes, where we can see them and observe their formation. Now, besides of this most violent of all windstorms, the tornado, which represents a vertical vortex column, we can observe in nature also horizontal formation of vortices. And I have here an experiment built up where we can see a special vortex formation due to the fact that we have a hot plate underneath on the bottom and a very cold one on top. And when we let the flow go through this channel, then due to the convective motion, the hot plate heats the air on the bottom, the thing goes up, the air goes up, hits the cold layer on top and returns again. And you see in this a row of counter-rotating vortices. Let me explain just shortly this little apparatus. We have here a box here with a glass wall on top, here on the side, where we can look into the channel. There's the channel itself. On the top we have a metal plate with dry ice on it, so that's real cold. From underneath we light it and have a glass wall, so the light comes on the glass wall and heats the glass wall so that the glass wall is hot. And then we suck this off by a blower. And when we turn on the blower, then we can see this makes a little noise, huh? Smoke develops. We have to look then into the thing from here. And when we look this way in, then we can see a picture which looks almost like this. There we have the hot plate. It's hot. That's cold. And there we have counter-rotating vortices. So the air goes here up, there down, here up, and there down. If we have this in nature, where the air goes up, clouds are forming. And we see long, mile-long cloud streets forming when we have cold air on top, a very cold layer on top, and the ground is heated by the sunshine. The energy which makes all these vortices comes in this case from the heat, and in the atmosphere also due to the layers with different pressure and density. You can observe also a vertical vortex forming from the ground, which we call the dust devil. And we have here a small glass box where we can make little models of such dust devils developing from the warmer surface of this box. It is enclosed so that we actually can see better how these vertical vortices, these dust devils, develop. The main thing is that we have a very warm layer on the surface itself, and when it rolls over due to the slow motion, it begins to roll, and then a vertical vortex spools out of it, as you see it very well in this box. The warm layer is what we see here as a smoke, and all these spooling up lines are actually vortices which are produced from this warm air going up and rotating as it goes up, because the air can only go through other air if it assembles into a vortex. And you see here very well that every of these fine lines is actually a vortex. Now you see it's very near to the formation and very near with the camera, and we can observe more distinct this rotational motion. But let's get back to our aerodynamics. We get too deep into meteorology. A vortex which we saw was the wingtip vortex. And here's a picture of a cross-section of such a vortex which we took in the 3D tunnel. Isn't this a striking similarity to something which you might have seen sometimes in pictures from the great telescopes which survey our stars in the sky? When you look at the picture of the wingtip vortex formation and you see a picture of a galaxy, of a spiral nebula, you see that something is similar in both pictures. I don't know what it is, and I doubt that we have a clear explanation of this similarity and whether there is any spiral motion in the sense as we observed it here. But you sit here on such instruments and apparatus and see these strange things develop, and you think it over, and you finally end up that anyhow many things stay unexplained to you. As the great poet says, mysterious even in the light of day, may never nature of her veil be freed, unless she willingly unveils to you nothing you force from her, with lever or with spoon. Goodbye, and auf Wiedersehen.
You have just seen The Story of the Vortex, the 11th in a series of programs explaining the secret of flight. Your host has been Dr. Alexander Lippisch, Director of the Aeronautical Research Laboratories of the Collins Radio Company. This program was produced for the Educational Television and Radio Center by the State University of Iowa.